Imagine telling your computer, hey, turn this PDF into a podcast, and it just does it. Or describing some wild scene and seeing it pop up in 3D.
Yeah, it sounds pretty futuristic, but that's actually the kind of thing NVIDIA is enabling for creators right now with artificial intelligence.
Exactly. So today we're taking a deep dive into what NVIDIA is doing to, well, make AI more accessible for developers, for creative folks.
That's the plan. We'll be looking closely at their new tools, NVIDIA Inference Microservices, they call them NIM, and also these things called blueprints.
Right. And the goal here is really to figure out how you, the listener, could actually use this kind of generative AI stuff locally, like on your own machine, without needing a master's in AI or, access to a massive cloud setup.
Precisely. It's about bringing that power closer to home.
Okay, so NVIDIA, most people probably know them for graphics cards, right? High performance gaming, that sort of thing. They've been leaders there for ages.
Absolutely. And those GPUs, those graphics cards, they're fundamental infrastructure for a lot of AI work already.
Yeah.
But what's interesting is seeing them move beyond just the hardware.
Yeah, they're developing their own AI models, their own architectures now.
Exactly. I mean, gamers are familiar with AI tech like ray tracing or DLSS, which make games look amazing.
You got
That's
it.
NVIDIA AI.
Yeah.
But now they're taking that core knowledge, that AI capability, and pushing it way beyond just graphics and gaming. They're aiming much broader.
Okay, so let's get into these NIMs, the NVIDIA Inference Microservices. What are they, in simple terms?
Think of them as like ready-made packages of AI power. They're built as microservices, which is a technical way of saying they're small, independent components you can easily plug into other software.
Okay.
The big problem they're trying to solve is this gap, right? Lots of people talk about AI, but actually using it in a real application, that's often really hard.
Yeah, the jump from theory to practice can be huge. So what's actually in a NIM? Is it just code?
No, it's much more. Each NM is a self-contained unit. It's got a top-tier AI model, could be something like LLM 3 for language or Stable Diffusion for images. Then it has really optimized engines like Tensor LLM to make that model run super fast. Plus, crucially, it includes standardized APIs, ways for other programs to talk to it, and all the background technical stuff it needs. Dependencies, libraries, all that.
So it's like AI in a box, almost, ready to deploy quickly.
That's the idea. Key in hand, ready to go. They claim deployment can happen in minutes.
Minutes? Seriously, what kind of applications could you build that fast?
Well, think about adding a really smart chatbot or virtual assistant to a company website. Or maybe generating realistic voices for narration. Tools for analyzing documents. Lots of possibilities.
Okay, that makes sense. Now, they also have these things called blueprints. How do they fit in? Are they different from NIM?
Yeah, they're sort of the next level up
Yeah.
in terms of ease of use. If NIM are the building blocks, the microservices.
Lego brick.
Kind of, yeah. Then blueprints are more like the pre-designed Lego sets. They're actual ready-to-use AI applications, though you can still customize them.
Ah, I see.
NVIDIA offers a library of these blueprints for different tasks, language processing, speech generation, video analysis, that kind of thing.
And I heard something about them working particularly well if you have an Nvidia graphics card, one of the RTX ones.
That's right. If your system has an RTX card, certain blueprints are optimized to really leverage the power of that specific hardware. You get better performance.
Can you give us an example? What does a blueprint actually do?
Sure. One really cool one is called PDF to podcast.
The one you mentioned at the start.
Exactly. Imagine taking like internal training documents, technical papers, maybe company report stuff that's usually dense text, and just automatically turning it into audio content you can listen to.
That's pretty useful.
Definitely. Or there are blueprints using that LLM 3 model to create intelligent customer service bots for different industries. And they're constantly adding more through partnerships.
Okay, so NIM are the core tech components. Blueprints are the ready-made apps built on them. It really sounds like simplification is the name of the game. How does a NIM actually work behind the scenes to make it so simple?
Well, the key is that all the complicated stuff, the configuration, the optimization, it's all pre-done by NVIDIA.
Right.
So each NIM package bundles the optimized inference engine, the actual pre-trained AI model, those standard APIs for connection, and all the technical dependencies. It just works.
So you skip all the setup headaches.
Exactly. You potentially skip weeks, maybe even months of figuring out how to tune the model, get the dependencies right, test everything, all that complex engineering work.
So what's the workflow like for a developer then? How do they use one?
They typically go to NVIDIA's AI platform, browse this catalog of microservices, pick the NIM they need, maybe one for image generation or text analysis, Then they just connect their own application to that NIM using the standard API. Pretty straightforward. And they can run it locally on their workstation, a server, or even customize it further if needed.
What are the main upsides then? Why go this route?
Simplification is number one. It just lowers the barrier to entry for using sophisticated AI. You don't necessarily need deep AI expertise on your team just to deploy something useful.
Makes sense.
And running it locally can be cheaper in the long run than constantly paying for cloud AI services, especially if you use it a lot. You own the hardware, you run it when you need it.
You mentioned a specific blueprint earlier for 3D work. That sounds really interesting for creatives.
Oh yeah, the 3D guided generative AI blueprint. That looks like a pretty big deal for anyone working in 3D design, animation, that sort of field.
How so? What does it let you do?
It basically lets you create complex 3D scenes more fluidly and with a lot more control than just typing text prompts. It uses tech from a company called Black Forest Labs and a visual interface called Comfy UI.
So it's not just text to 3D then. What's the difference?
The key is the interactivity. Instead of just typing create a forest scene and hoping for the best, you can actively get in there and modify the scene in real time.
Like move things around, change the lighting.
Exactly. Change camera angles, swap objects, tweak details directly in the 3D space. That level of fine-grained control is really hard to get from text alone. You're integrating generated elements into a scene you can actually manipulate.
Okay, that sounds powerful, but I guess you need some serious hardware for all this. What are the requirements?
Yeah, performance is definitely best with the newer Nvidia cards. The documentation points specifically to the latest GeForce RTX Series 50 GPUs.
Series 50, why those specifically?
They have what Nvidia calls fifth-generation tensor cores. These are specialized processors designed specifically for AI calculations. They offer a huge performance uplift, something like 3,352 TOPS, which is a measure of AI processing speed.
And what does that translate to in real terms?
Well, they quote figures like image generation being up to 13 times faster and AI model training being 30 times more efficient compared to previous generations. Running locally becomes much more feasible.
Right, so the better your RTX card, the better these NIM and blueprints will run.
Pretty much. The platform actually lets you filter the available NIM and blueprints based on the capabilities of your specific RTX card.
And with that kind of local power, what could you realistically do on your desktop?
Things like really fast content creation, maybe automated video editing assist, that detailed 3D manipulation we talked about, running quite capable chatbots or assistants locally without needing the cloud.
Okay, so it sounds like investing in a good machine is key. Are there like pre-configured PCs optimized for this kind of work?
Yeah, actually, they mentioned that partners like Material.net are offering PCs specifically designed with Nvidia, optimized for local AI using NI.
Oh, interesting. What kind of specs do they have?
They listed a few tiers, like a PC Moon IA with an RTX 5060 Ti and a Ryzen 5 9600X, then a common IA with a 5070 Ti and Ryzen 7, up to an Astral IA with a beastly 5080 Ti and a Ryzen 9 9950X 3D, all with plenty of fast RAM too.
So options depending on your budget and needs. Okay, let's try and wrap this up. The big picture here, NVIDIA making a serious play to get AI tools into more hands.
Absolutely. NEM and blueprints are fundamentally about lowering the barrier, making generative AI easier to deploy, easier to use, and importantly, making it run well on local hardware that developers and creators might actually have.
And the potential impact is pretty significant across different creative fields.
For sure. Content creation, how we handle documents, 3D design, this could really shake things up.
So here's something to think about. As these powerful AI tools become more common on our own computers, our local devices, how does that change the game? Does it shift power away from the big cloud providers? Maybe empower individual creators more?
That's the million-dollar question, isn't it? It could really democratize access to cutting-edge capabilities. Definitely something to watch.
Well, this deep dive was brought to you by Le Podcast de Philippe. If you found this useful and want more analysis like this, please do help us reach our goal of 1,000 subscribers. It really helps us keep doing these.